Hi, welcome to the next video on applied econometrics. In this video, I will review the concept of hypothesis testing. A hypothesis is a claim whose validity is to be tested by using empirical data. So it is a claim which can be tested with the help of sample data. The hypothesis can be true or false, and our purpose here is to ascertain whether the claim made is correct or not. And we use sample data in order to test that. For example, someone claims that investing in education of kids has nothing to do with their earning capacity. So this is a claim made by someone, and this claim may be true or this claim may not be true. And we have to verify this by taking data on the years of education of kids and the earning capacity. So to illustrate the process or procedure used in hypothesis testing, we take here a simple example where we have to test a claim made about the population mean. So there are certain steps in hypothesis testing. The first and the most important step is the formulation of hypothesis. So we generally construct two hypotheses. One is the null hypothesis and the alternative hypothesis. So for instance, we have to test the claim that the population mean is 50. We formulate the null hypothesis as the population mean mu is 50. The alternative hypothesis, which is denoted by S1, can be constructed in one of the three ways. The two-sided alternative hypothesis can be expressed as mu doesn't equal to 50. The one-sided hypothesis, the right hand hypothesis and the left-tailed hypothesis. So this is the right-tailed hypothesis, right-tailed alternative hypothesis, and this is the left-tailed alternative hypothesis. So the logic behind this is that this hypothesis, this alternative hypothesis is accepted whenever the mean value is too far below 50 or too far above 50. Like in this distribution, if the mean value is far below, we reject the hypothesis, or the mean value is quite above the hypothesized value, we again reject the hypothesis. Whereas in one-tailed hypothesis, we reject only when the mean value is far above. So this is in this case right-tailed alternative hypothesis, or when the mean value is far below. So the main difference between the single-tailed hypothesis test and both-tailed hypothesis test is the determination of the rejection region. In two-tailed test, the rejection region lies on both part, and we reject if the value of the test statistics that we calculate is quite low or quite high. But in one-tailed hypothesis test, we reject the null hypothesis if the calculated statistics is quite high in right-tailed hypothesis or quite low in left-tailed hypothesis. So the second step is the acceptance and rejection region. Just I talked The acceptance and rejection region depends on whether we have formulated the two-sided alternative hypothesis or one-sided alternative hypothesis. Besides that, the acceptance and rejection region depends upon the level of confidence that we want to maintain. Level of confidence. So, for example, if we want to maintain 95% confidence level, the rejection region is 5%, and in two-sided test the rejection region is 2.5% on the left and 2.5% on the right, and the middle one is 95%. So if the level of confidence is chosen to be 99%, the rejection region is 1%, 0.5% on the left and 0.5% on the right. Whereas in single tail test, if the confidence level is 95%, so this is the 95% acceptance region and 5% on the rejection region on the left only. So no rejection region on the right hand side. Here also, if 95% confidence interval is chosen, the rejection region is 5% on the right only and no rejection region on the left hand side. So in this way, the choice of the confidence level helps determine the rejection region, and the type of alternative hypothesis says whether the rejection region is on the both side of the distribution or a single side of the distribution. After determining the level of rejection and acceptance, we calculate the test statistic. For instance, in this case, we have to test the claim about population mean, and we can use Z statistics since sample size is quite large. And the formula for calculating Z statistics is x bar minus mu divided by sigma over under root n. So this statistics is normally distributed with mean 0 and standard deviation 1 by the virtue of central limit theorem. So we calculate this statistics and we compare the calculated value, which here we call the actual value. So actual value here is the calculated value. So G actual is the calculated value of G from step third. So if G actual is less than or equal to the critical value of G, we fail to reject the null hypothesis, and if the absolute value of the actual G that we calculate is greater than the critical value of G, we reject. So the critical value of G can be found from the normal table. The most common value used is for 95% confidence level, 95% confidence, and two-sided test. So for 95% confidence and a two-sided test, the value of G is 1.96. So we compare the value of calculated G from step third to 1.96. If it is less than or equal to 1.96, we fail to reject the null hypothesis, and if the calculated G is greater than 1.96, we reject the null hypothesis. So we can illustrate the procedure of hypothesis testing with an example. Suppose that we have drawn a random sample of size 400 from a population and the sample has a mean of 200 and a standard deviation of 20. We have to test the claim that the population mean is 300. So in step first, we formulate the null hypothesis. Population mean mu is 300, and the two-sided alternative hypothesis mu is different from 300. So in step 2, we specify the level of confidence. So the level of confidence here is 95%, and this alpha is the level of significance, which is 1 minus the level of confidence. So level of significance is 5%. So in step 3, we use here Z statistic, as the sample size is fairly large, 400, and the Z statistics can be calculated as x bar minus mu over sigma upon 110. So Z is 200 minus the claimed value of population mean is 300 divided by 20. So since our sample size is fairly large, we use the sample standard deviation instead of population standard deviation divided by sample size 400. So this leads us to the fact that the calculated value of Z statistics is 100 in absolute sense. Now we compare this calculated value of Z statistics with the critical value. Since our hypothesis test is a two-sided hypothesis test and the confidence level is 95%, the critical value of G is 1.96. Since the calculated G is 100 in absolute value, which is greater than 1.96, we reject the claim that population mean is 300. Thank you for watching this video, and please be connected with my channel to watch more videos in the future.